If you sat down at a world-class restaurant, you'd never expect the chef to build your meal from a pile of unwashed, random ingredients, complete with dirt, weeds, and a stray shoe. We expect the same level of care from the AI we use every day. But computers can't simply sit down and read the internet the way you or I do. The internet is a chaotic sprawl. Billions of raw social media posts, scanned books, and scraped articles that are completely filled with typos, broken formatting, and endless repetition. If a model tries to learn directly from this mess, it ends up memorizing our human mistakes and bad grammar, rather than learning how to actually think. Before the learning ever begins, the raw text of the internet has to pass through a massive, invisible preparation phase called the data processing pipeline. The first station is the sink. If you feed a computer garbage, it learns garbage. We must start by scrubbing off the mud. We wash the data, stripping broken computer code, fixing formatting errors, and tossing irrelevant noise. Next, we have to deal with the echoes. We search millions of documents to find and remove endlessly copied text. This is critical for a balanced model. If an AI reads the exact same paragraph 10,000 times, it starts to believe that one specific paragraph is the only thing that matters. Look at how this works in action. A massive, chaotic block of overlapping text shrinks and organizes down into a single, pristine paragraph. By cutting out the clutter, we actually make the data more valuable. This deep cleaning ensures the AI builds its knowledge on reliable, accurate foundations, which helps prevent it from giving biased or skewed answers later on. Moving over to the cutting board, we face a new problem. Even a clean, washed sentence is too large for a computer. It must be broken down. We do this by chopping whole sentences and words into manageable, bite-sized pieces that the computer can easily digest. To handle complex vocabulary, the word unbelievable cleanly slices into discrete chunks, un, believe, and able. Watch these chunks rearrange and snap together with pieces like do and ing. This lets the AI mix concepts to understand brand new words. This step is mandatory because underneath the surface, an AI model doesn't see human letters at all. It processes mathematics. By transforming unpredictable language into these identical units, we give the computer something its algorithms can actually calculate. Now we arrive at the spice rack. Having clean, perfectly chopped ingredients is a great start, but a chef also needs to understand how those ingredients relate to one another. To help it understand, we create a mathematical map that shows the AI exactly how words relate to the words around them. This map organizes words by relationships.
The word apple appears, clustering right next to pie, tree, and fruit. Zooming out reveals a second apple clustering far away, next to phone and computer. This teaches the AI that context changes meaning entirely. This process turns flat text into a multi-dimensional map of meaning. It teaches the AI to see the hidden connections in human language. But beware, if a chef memorizes one specific recipe too perfectly, they will blindly repeat the exact same motions every single time, unable to adapt. This is the memorization trap. If our data lacks diversity, the AI learns its training documents perfectly, but entirely loses its ability to think. The moment you ask it a brand new question, the model completely panics because it hasn't learned to adapt. To build a truly intelligent model, our pipeline must provide a balanced diet of information. This teaches the AI to understand the rules of language, rather than just reciting a script. Finally, our clean, chopped, and mapped data is ready. We can finally hand it over to the model so the actual training can begin. Because we took the time to meticulously process the data, the AI didn't just memorize specific internet posts. It learned the underlying art of human communication. The next time you type a prompt into a chatbot and get a brilliantly human answer, you are seeing the result of all this hidden preparation. That intelligence starts right here, in the invisible prep kitchen, long before the model ever begins its training.